Today we're talking about intermolecular forces, IMF forces, in covalent compounds. There are 4 types, and we will go from the weakest to the strongest attractive forces. Starting off with London dispersion force, which is LDF, then dipole-dipole force, DDF, and then hydrogen bonding, HB, and last strongest ion-dipole force, IDF. London dispersion forces are weak because they are created by temporary dipoles. And how those temporary dipoles are created is because atoms are usually symmetrically distributed with their electrons evenly distributed throughout the structure. But those electrons can then move and shift to one side of the structure, producing these temporary dipoles. And this temporary dipole is created from the partial negative on one side of that structure and partial positive on the other side. This is an asymmetrical distribution of electrons. What happens is one atom has this induced temporary dipole, and then it creates another atom to induce a dipole as well. And so those two atoms will have parts that are positive on one side and then negative on the other side of a neighboring atom, thus creates this London dispersion force between those particles, the attractive force between those particles. If you look at this, halogens tend to exist as diatomic molecules. And if you look at the evidence here, it shows that there must be some kind of attractive reasoning for the attractive force increasing going down the halogen, group 17. And that must be that those atoms that have more shielding electrons or more electrons overall create stronger dipoles, temporary dipoles, and thus the boiling point increases. If you look at my periodic table in my classroom, fluorine at room temperature is a gas, as well as chlorine. Bromine is a liquid, and iodine is a solid. For that to happen, as you go down that group, the attractive forces must be increasing, and thus the London dispersion forces must be increasing. And that is due to the increasing number of shielding electrons or electrons overall. Likewise, with the noble gases, notice the boiling points are increasing as you go downward, and that means the attractive forces are increasing, the London dispersion forces. And that's because these atoms, as you go lower, have more electrons and thus stronger, greater London dispersion forces. Dipole-dipole force, DDF forces, are due to permanent dipoles, unlike London dispersion force, which are due to temporary dipoles. With the permanent dipoles, so the permanent dipoles are occurring because this is a polar molecule, with chlorine being more electronegative, and so that's why there's a partial negative charge on the chlorine atom and a partial positive on the hydrogen. So this is a permanent situation for this atom. Always chlorine in HCl is going to be more negative and hydrogen positive. And so if you look at an adjacent molecule of HCl, that hydrogen end is going to attract the chlorine atom of an adjacent molecule of HCl. And likewise, the chlorine is going to attract the hydrogen end of an adjacent HCl molecule. So there are attractive forces between these particles. And these forces are dipole-dipole forces, DDF forces. Hydrogen bonding occurs because you have very strong permanent dipoles. And the strong permanent dipoles are created within the water molecule, as you see here, because hydrogen is attached directly to an electronegative atom, or the most electronegative atoms, like fluorine, oxygen, or nitrogen. In this case, it's oxygen. This creates a very strong dipole right here between the oxygen-hydrogen atoms, as well as the other oxygen-hydrogen atom, making oxygen highly negative, so the charge increases. Thus, hydrogen is also going to be highly positive, Therefore, the intermolecular forces, because the charges are stronger, are going to be even stronger. And so that's why hydrogen bonding is really for polar molecules, but even more for the very polar molecules, where you have hydrogen attached to FO or N. The strongest of the intermolecular force is ion-dipole forces, IDF. And these are they're strong because you're looking at a fully charged ion and polar molecules, like water. This is actually a water molecule, which is polar. When this fully charged ion is attracted to the opposite parts of the water molecule that are charged, or the opposite charged parts of that water molecule, you have what is called ion and then dipole force, because the dipole comes from the polar molecule. Only polar molecules have permanent dipoles. And so this is strong because it involves a fully charged ion with partial charges in the polar molecule. Whereas hydrogen bonding and dipole-dipole are really just partial charges that are attracted to other partial charges. And sometimes the partial charges are even stronger partial charges attracting other ones. Ion-dipole forces occurs when ionic compounds are dissolved in some kind of polar solvent, like water. And this concludes our 4 types of intermolecular forces, starting with blended dispersion forces into dipole-dipole force, hydrogen bonding, and then ion-dipole. I hope you found this video to be very helpful. Please let me know if you have any questions in class.